Today we're going to talk about inverse functions. First, we're going to talk about how to take a function and find its inverse, and then we're going to talk about how you can look at two inverse functions and determine if they are indeed inverses or if they are not. So in examples 1 through 3, we are given three types of functions that we're going to look at how to find the inverse. In order to find the inverse of a function, the first step is to take the function f of x, or whatever else is listed, and change it to a y. So we will write this as y equals negative 6x minus 15. Now, you're going to take your variables, and you're going to swap the x and the y. Only the x and the y will move. None of the numbers will move. They will all remain in their original places. So now I have x equals negative 6y minus 15. And then the final step is to solve for y. When I solve for a variable, I'm trying to get it completely by itself. So the first thing I will do is add 15 to both sides. So now I have x plus 15 equals negative 6y. And then finally, I will divide both sides by negative 6. So that y is equal to x plus 15 over negative 6. Now, remember, we've talked about this in the past. If you have a negative in the denominator, you need to divide through by that negative. In this case, it's going to change the signs of all three terms. So I will get y equals negative x minus 15 over a positive 6. Now notice, since I had a y at the original part of the problem and I have a y here at the end, I need to differentiate them in some way. The way that we write an inverse is by putting a negative 1 on the y. In this second example, we're going to follow the same exact steps, but you may be looking at it and realize there is a fraction. So I'm going to take you through how to solve when you have a fraction. In this case, we have g of x, but we're going to start off by taking the g of x and changing it to y, just like we did in the previous problem. Now that we have made that change, we will swap the x and the y. Remember, it's only the variables that change places. None of the numbers will move. So x is equal to negative 16 plus 9y over 4. And now we want to solve for y. I have three numbers that I need to get rid of, but I can't even get to the negative 16 or 9 without removing this 4 first. Since these numbers are divided by 4, I will multiply both sides by 4. That gives me 4x equal to negative 16 plus 9y. The next step will be to add 16 to both sides. Now I think I'm going to write my answer up here. I have 4x plus 16 equal to 9y. And the final step will be to divide both sides by 9. So y is equal to 4x plus 16 divided by 9. Now don't forget, let's denote that this is the inverse by putting a negative 1. Sometimes you might see this answer split. It is okay to do that also. You could write this as 4x over 9 plus 16 over 9. These are equivalent answers. In this third example, we have a constant and we have a fraction with a variable. we're going to find the inverse the same way. We'll start off by changing our f of x to a y. Next, we will swap our x and our y. Now that we've done this, we will solve for y. In this case, I'm going to start by subtracting 3 on both sides, which gives me x minus 3 equal to 2/5 y. If you ever need to get rid of a fraction, this one is multiplied, and the typical response would be to divide it on both sides, but we can't divide by a fraction. So instead, we multiply by its reciprocal, 5/2. So my final answer is y equals 5/2 x minus 15/2. Again, mark this as your inverse by putting a -1. Also, realize if you're asked for an equivalent answer, this could be written as 5x minus 15 over 2. Now it's time to look at whether or not two given functions are indeed inverses. Now it's time to look and see if when we are given two functions, are they indeed inverses of each other? The way that we do this is we're going to take one function and plug it into the other function. It doesn't matter which order. You can choose which one you want to plug into the other. If they are inverses, as you simplify the problem, you're going to get simply an x as your answer. All right, let me show you how this is done. I'm going to take this second function and I'm going to plug it into the first function where you see the x. Make sure that you use parentheses when you do this. So I have 3 times 3 plus 2x over 3 minus 3, and then all of that is over 2. Now when I multiply, don't forget, if you have a whole number and you're multiplying times a fraction, put that whole number over 1. You are allowed to cross cancel. Something in the numerator can cancel with something in the denominator. So now I'm left with 3 plus 2x minus 3 divided by 2. Look for things that can be combined or can cancel. The 3 and the -3, they cancel each other out, leaving me with just 2x divided by 2. And now finally, the 2's can cancel. So I am left with just x, which means yes, these are inverse functions. We're going to do the same process. Once again, it's totally your choice. It doesn't matter which one you combine. But I'm going to take the second one again, and I'm going to plug it into the first. And just like I did before, I want you to use parentheses. So I've got -1/4, and I'm going to plug in 6 plus 3x over 2 plus 1/4. When you're doing a fraction times a fraction, you will take the numerator and multiply it times everything in the numerator. That's going to give me -6 and -3x. Then I'm going to do denominator times denominator. That'll give me an 8. To combine these two fractions together, I do need to get a common denominator. A common denominator for these would be 8, which means the first fraction will remain the same, and the second one will become 2 over 8. Now, I can write them as one large fraction, and I have -6 minus 3x plus 2. When I combine the -6 and the 2 together, I get -4. But here's the deal. I don't need to really even go any further because these are not going to combine, things are not going to cancel, and there's no way that this is going to simplify to an x. So this is a no. These are not inverse functions. Here's my third and final example. Just like I did before, I'm going to take the second function and I will plug it into the first. That gives me -1 minus 3/5 times -5/3 x minus 5/3. I'm going to distribute the 3/5 to both of these fractions. Be careful of your signs and don't forget to multiply those also. So I have -1 plus 15 over 15 is 1, and negative times negative is positive. So a positive 1x. Then I'll multiply -3/5 times -5/3, and that's also going to give me a positive 1. The -1 and the positive 1 cancel, leaving simply an x. So this is an example again. Yes, these are indeed inverse functions.